Okay, so today's video is going to be about transformations with graphing, and then also, depending on your teacher, also how to write the equations when transformations happen. So when we talk about transformations, we are looking for, is the graph opening up, is the graph opening down, has it moved left, right, and the reflection over the x-axis. So if we look at the first example, here is parent graph. So this is y equals x squared. Okay, so hopefully you recognize that this would be a quadratic. Okay, and then once again, depending on your teacher, you might have to write the function. For my class, you need to do that for quadratic, absolute value, and square root. Okay, so this equation, we need to look at how the graph moved, and it moved to the right 2 and down 1. Okay, so we can go ahead and write that in on the transformations, but then we need to model that in the equation. So inside the parentheses, it'd be x minus 2 squared minus 1. Okay, so remember that it's kind of like the opposite on the inside. Your general equation for a quadratic is y equals a times x minus h squared plus k. So since we're subtracting a positive number, it's x minus 2 on the inside. You should also check to make sure that a is 1 and then it's opening up. So we know it's opening up, so the a value is going to be positive. And then we went up 1, we went up 3, we went up 1, we went up 3. So the a value doesn't change. Okay. The domain, remember, always is negative infinity to infinity. And then the range, since this graph is opening up, we're going to start at the k value, which in this case is negative 1, and go to positive infinity. If a is negative, we come up from negative infinity, and then we stop at the k value. So the x-intercept is where the graph crosses the x-axis, and in this example, we actually have two of them. We have at 1, 0 and at 3, 0. Make sure that you write your x and y intercepts as ordered pairs, and then the y-intercept is where the graph crosses the y-axis, which for us is up here, and that's going to be at 0, 3. Alright, so that's an example of a quadratic transformation. The next one we're going to look at, hopefully you recognize v for absolute value. Okay. This is the parent function right here. The parent function is y equals the absolute value of x. And then the general equation is a times the absolute value of x minus h plus k. So we want to see how is the red graph changed from the blue graph. Well, we went to the right 2 and we went up 1. Okay. Graph is opening up, so we don't need to worry about saying reflect over the x-axis. And then we should check the a value. For the general equation, we go up by 1 and over 1 each time. And in this example, we do the same thing. So our a value didn't change. Okay. So the domain for an absolute value function is always negative infinity to infinity. And then the range, since the graph is opening up, we're going to start at the k value, which is 1, and go to positive infinity. Okay. The x-intercept is where the graph crosses the x-axis, which is down here. Notice that our red function does not touch the x-axis at all, so the x-intercept is none. Okay. And then the y-intercept is where the graph crosses the y-axis, so we have 0, 3. Okay, the last thing that we need to do is actually write the equation for the transformation. Okay, so the a value stays the same. we went to the right 2, so this is going to be the absolute value of x minus 2, and then we went up 1. Okay. If we were to say that the graph opened down, then the transformation would say reflected over the x-axis, and we would have a negative number in front of the absolute value bars. Okay, there is an example of that later on. Alright, so let's go ahead and take a look at the next example. Oftentimes we get asked, how do I tell the difference off the graph if this is a square root function or if this is a logarithmic function? Well, first of all, notice that there's no asymptote graphed and there's no line to say that there is an asymptote. So that should be your first indicator that this isn't a log function. Okay. Also, notice that in the parent function, we go from 0, up 1 to the right 1, and then up 1 and to the right 3. So this is going to be a square root function. Okay. So then let's look at the red graph from the blue graph. How did it change? So we went right 1 and down 1. Okay. And we don't see that it flipped down, so we don't have to worry about it reflecting over the x-axis. And then just check the 1, 3, 5, and that's the same as well. Okay. All right, so for the domain, we start at the h value, or the starting point. So this is going to be from 1 to positive infinity, because we can't take the square root of negative numbers and get real numbers back out. And then for the range, since our graph is continuing up in the positive direction, we start at -1 and go to positive infinity. Okay. X-intercept is where it crosses the x-axis, and in this case that's going to be 2, 0. And then the y-intercept is where it crosses the y-axis, and we actually don't have any, so the answer is none. Okay, and then the last thing we need to do is write the general equation so that we can write the transformation. So here's the general equation for a square root. Okay, we need to substitute this in. So y equals the absolute value of x, sorry, not the absolute value, the square root of x minus 1 and then minus 1 on the outside. Alright, next example, notice that on here you can see that there's an asymptote drawn in. So this is going to be either an exponential or logarithmic. We are exponentially growing here. So this is an example of an exponential function. Okay. And then the asymptote is going to be y equals 0. Okay. For the domain, exponential, there's nothing that we can't plug in, so -infinity to infinity. But there is a restriction on the range. For the range, you start at the asymptote and either you go up to positive infinity or you come up from -infinity and you stop at the asymptote. Well, since we are above here, we are going to have an open bracket at 0 and go to positive infinity. We do not include the asymptote. Remember, that's a line that you approach but never touch. Okay. Now let's make a careful observation here. The asymptote in this example is the x-axis. So would it be possible to have an x-intercept? The answer would be no. Okay. And then where does the graph cross the y-axis? It would be at, if you heard that, that's my dog shaking, 0, 1. Okay. Don't worry, at least for my class, about writing the function for the transformations, because exponential, we really aren't going to focus too much on transformations, just how the asymptote changes. Okay. So the next example is going to be a logarithmic function. Okay. The asymptote here is a vertical line, so that's going to be x equals 0. And hopefully we make it the connection from the last example that since the asymptote is the y-axis, there cannot be a y-intercept. Okay. The domain, that we do have a restriction on the domain. Okay. We have an open bracket at 0 and we go to positive infinity. But for the range, we cover everything. So notice that we come up from negative infinity, and we go to positive infinity for the range, which is up and down. Okay? And then the x-intercept is going to be 1, 0. Alright, so I know it says the examples are partner, but I'm going to do one more on here, and then after that you can go ahead and pause the video and try the next 4 examples on your own, and then go ahead and play and see if your answers match up. So let's first do the partner example together. Okay. Hopefully, absolute value, we recognize V for absolute value. Okay. And this graph definitely has changed. Notice that the parent graph is not drawn in, but of course you can always draw it in if you would like, if it helps you see the transformations. Okay. So first of all, our vertex, we went up 4. We are now also opening down, and in the parent function we went up 1 over 1, but in the new function we went down 2 over 1. Down 2 over 1. So that is definitely going to change our equation. Okay. So let's go ahead and write these down. We went up 4. We reflected over the x-axis. And then our graph got narrower. Okay, so you can just sum it up by saying narrower or wider. And then the equation for the graph, so here is the general equation. Okay. So in our example, we need to have a negative 2, absolute value of x, the h value didn't change, plus 4. Okay. Once again, how did I get the 2 or negative 2? It was opening down, so it's going to be negative, and then went down 2 over 1, down 2 over 1. Okay. Domain is always negative infinity to infinity. The range this time, since it's opening down, we're coming up from negative infinity. So negative infinity to 4, and we include it. Okay. X-intercept, we actually have 2 of them, negative 2, 0, and 2, 0. And then our y-intercept is our vertex in this example, 0, 4. Okay. Alright, so go ahead and hit pause, and you can do the next 4 examples on your own, and then you can go back and test to see if you got them right or not. So the explanations won't be on there, but you will just be able to check your answers. Okay, here are the answers for the first 2 examples. On number 2, you did have to write a transformation equation. It went to the right 2 and up 1. Okay. For number 3, just a special note here in red. If one of your intercepts is 0, 0, then it follows that the other one should also be 0, 0. So you should never have 0, 0 for one and not the other. Okay, because it's at the same point. Okay, number 4, we had to write a transformation equation. So notice that the graph is going down, so that means it reflected over the x-axis. So that means your a value must be negative. Okay, but we still did the 1 and the 3, so we leave it as is for the a. Okay, so our range will change a little bit. We'll come up from negative infinity and stop at 2. And then for the last example, it's a logarithmic function. There's no y-intercept because we never crossed the y-axis. So this concludes the video for day 2. Your homework will be worksheet 2, and then there will be one more video for you guys to watch about domain and range. Thanks, and have a good day.